let's get ready for chapter
3.
my face here. Chapter 2.
3.
A lot of graphing, a lot of pictures, a lot of moving shapes around. I immediately regret moving my face over here, so let's move it back over here. You're going to see me move my face around a lot. Before we can really understand what to do in this chapter, we need to know how to graph points on a coordinate plane. So the way you do that is, for whatever reason, this problem's in reverse alphabetical order. I'm not sure why. If you have a point and the first number is positive, you go right. If the second number is positive, you go up. So what we're going to do is we're going to go right 1, 2, 3, 4, 5, and we're going to go up 10 and put our point there and label it J. Okay, and let's do it again. So this is what I'll do. I'm going to write out a point right here. Positive first number means right. Negative first number means left. Positive second number, which is the y value, means up. And negative y value, the second number, means down. If it's 0, you don't move. All right, so the second one, positive 1, positive 9. So write 1 up 9, put a dot, call it I. Okay. H is positive 6, means right 6. Negative 9 means down 9. Put a dot there and call it H. G is negative 8. Negative 6, positive 8. So we start out by going left 6 and up 8. And we can call that G. F is 9, 0, which means go right 9. 0 means don't move, call it F. Let's see what other colors we can get. How about a nice pink? E is negative 6, 0, which means we go left 6, don't move up or down, call it E. Nice light blue, nice cyan. D is negative 8 and negative 4. So let's go left 8, down 4. Call it B. C is 5, 0. So let's go right 5. Don't move. Call it C. B is negative 1, negative 1. So B is going to be left 1, down 1. And A is negative 8, negative 1. So let's go left 8, go down 1, call it A. All right. Graphing coordinates. Now what I want to do is, can I fit my face there without ruining anything? Yep. Now what I want to do is name each point. So I have a bunch of points, and I have to go to those points and give me the distances or the directions that I have to get there, and then turn those words into a point. So if I were to say right 6, up 3, then my point is 6, 3. If I were to say left 2, up 1, then it would be left 2, which is negative 2, up 1, 1, negative 2, 1. So looking at A, the way that I would get to A is I go left 10, up 2. So A is left 10, up 2. Okay, left 10, up 2. B is over there, right 6, up 10. So B is right 6, which is positive 6, up 10, which is positive 10. C looks like it's left 8, down 3. So C is left 8, negative 8, down 3, negative 3. D is left 8, down 8. So D is negative 8, negative 8. E is right 1, down 5. So E is right 1, down 5. 1, -5. F is right 2, down 4. F is right 2, down 4. G is left 7, up 8. So if G is left 7, that's -7. Up 8 is +8. H is right 2, up 5. So H is going to be right 2, which is +2, up 5, which is +5. I is right 8, down 2. So right 8 is +8, down 2 is -2. J is left 7, down 5. So left 7 is -7, down 5 is -5. And K, is that it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I did 10 of them. Cool. Good. Great. Good. Let's talk about what we're going to be dealing with in chapter 2. Okay, there's 4 main things that we're going to be dealing with. First things first, translations. Translation is when you just take an object and move it. Okay, you slide it, as it says here. It doesn't change shape. It doesn't flip. It doesn't rotate. It's literally you take this guy and move it over there. It doesn't go sideways in any way. It doesn't go diagonal. You just move a shape. Okay, translation is just moving a shape. What angles have equal measure? All of them. What sides have equal measure? All of them. Okay, so your shape doesn't, it's like if you were to play Tetris and you just go left or right and don't rotate anything, that's a translation. A reflection, right below it, is exactly what it sounds like, a mirror image. Okay, so if over here, if we were splitting, if we were to put a mirror right in the middle, and if I were to put an object right here, it's going to be the same distance. Okay, so better yet, if I were to label these points here, if I were to call you A, that would match up with that guy over there. If I were to call you P, that would match up with that guy over there because it's a mirror image. Okay. What angles have the same measure? All of them. The angle measures wouldn't stay the same or wouldn't change. And what sides have the same measure? All of them again. Your shape does not get bigger. It does not get smaller. It does not stretch out. It does not shrink. It doesn't rotate. It just goes flipped over or flipped up. Okay? Definition is the spinning of a shape or an orientation of a shape by a certain number of degrees around a point. So I'm literally just taking my object. And I'm rotating it. Okay, I'm not making it a mirror image. I'm not just moving it. I'm taking my object and I'm spinning it. Okay, I still have an iPhone. It does not get bigger. It does not get smaller. It does not become something brand new. So what angles have the same measure? All of them again, because this guy is just going to move to that guy. This guy is going to move to that guy. Okay, this guy is going to move to that guy. Everything rotates. They all have the same size too. Nothing gets bigger, nothing gets smaller. The last one is where things get bigger or smaller. Dilation is when you grow or shrink a shape. I give you a number, and that number tells you whether that thing gets bigger or smaller. The larger the number, the bigger it gets. The smaller the number, the smaller it gets, so on and so forth. Okay? All of the angles stay the same, but the sides don't. That's supposed to say none, and there was a lag there. So it just gets bigger or smaller. So literally you just take something and you stretch it. It still looks like the same thing. It's like if I were to hold an iPhone here and an iPhone Plus, you know, it's still the same dimensions. It would just be like me taking this guy, going and stretching it out a little bit so that it looks bigger. Okay? It doesn't all of a sudden make it like a wider looking iPhone. All right, so those are our 4 guys or gals. Okay? What single transformation was applied to get from A to B? Looks like to me that that's a reflection. It looks like to me that I have an invisible mirror living right down there, and everything just goes from that side to that side. It flips over. Reflection. What single transformation was applied to quadrilateral A to get to quadrilateral B? Well, it looks like I just took A and moved it down. So that would be a translation. Okay. Notice that in reflection and translation, my shapes are still the same exact size, same exact shape. I mean, this guy is the same shape as that guy, it's just flipped. It's the same thing. Name the transformation. It looks like to get from red to blue, it's not me just moving it. It's not a mirror image. This looks to me like a rotation. It looks like if I were to take my shape, right, and my shape looks like this, and just kind of go like that. There's its new spot. Now the last one is a trick problem, because you're going to want to say dilation, because you're like, oh, that shape was small and it got big. It's not. It's actually none of them. And if you're wondering why is it none of them, well, because this shape turned into a completely brand new shape. All of a sudden I have this skinny, small red shape, and then it's almost the same height, but it's super stretched out. It got wider. I can't do that. You can't just make a brand new shape and call it something. So that's a trick problem. That's a none. That's a none, just like if you're in a Catholic church. Well, that's it for Chapter 2. Chapter 2 is a tricky one, so make sure you know your shapes, make sure you know your graphs, and that should do it. Bye!